bit of wind making some watts, and there's lots of sun making juice from solar. It's a good day. The sun is high and the wind is picking up some more. It's AC. Oh my goodness, can't even read it. It's 0.66 at the volts. So when there's enough wind, this kicks in to the bulb prime, if you will, some juice to the motor to start spinning, and drops out when there's not enough wind, just to give it a kickstart. There's no boost in here right now. I just let it the voltage speed build up to 18 volts, 19, spin up, so that it actually pushes juice, because it's about 19-20 volts from the solar, so that's how much it's going to overcome. So it works without a boost. It just lets the speed spin up to producing 18 volts or more, pushing 18 or more. So that's good. I don't need a boost, which is the power supply or not. Okay. So there's just nothing to keep kicking it in. It's not quite enough to sustain. Actually, there's quite a bit. I'm driving it. And getting some pretty good readings here. The green light is on, and it's operating normally. Producing. to about 360 to push power. 19 kilometers per hour wind. With kickstart, no boost. So it's allowing it to spin up to produce 18 to 20, 18 or more volts. So it's running a lot faster, but uses no boost energy. If the wind is about 16 kilometers an hour, which is not enough to run without boost, then I just plug in the boost adapter at 12 volts, and then it doesn't let it spin up that high. So basically I add 12 volts in series with a windmill, and starts producing power when it's generating about 6 to 12 volts. So that means it's spinning about 2 or 3 times slower than now. So advantage is it's running slower with a boost, but if you have enough wind, then it doesn't make sense to run the boost and use some energy, because the power needs to go through the boost, and thus using energy through efficiency. So now it's gonna stop, and you'll see the spin up the next wind gust. So as you can see, wind is not really continuous. And changing direction. Now it's coming from east. As opposed to northeast. There it goes. producing. It's kicking about 100 watts and peaking up to 150, 300, 200 or more. So if you want to see more information about this do-it-yourself windmill, you can start watching from video 1. There's a lot of explanation of what I used for different things. So basically it's a motor generator for a permanent magnet motor from a treadmill. This one is 3 horsepower, so you can push out 20 amps at 2100 watts at 3800 RPM. Well, obviously it's not spinning up to 3800 watts unless you had a gust of 80 kilometers an hour or something. Right now it's really I think I'm going to go out and see if I can get the reading recorded. So I'm going to stop this now let's see what we're pushing out. So again it's northeast. Northeast-east, and it's not quite steady. There's wind gusts, but let's see what we got over here. Okay, this data here, the amps, is also with a solar panel. It's supposed to be 100 watt solar panel, putting out about 2.5 amps. So you can see the peak amps. $371. So 2 times. And that was about 200 watts. That's the multimeter there. It's just measuring voltage on the generator. Now let's turn it back on. This is the control that I built. You can also see a video and schematic on it in previous videos. So right now it's producing 8 volts. 12 volts, which is not quite enough to push in amps. Okay, so at this lower steady speed, I would benefit from plugging the 12 volt adapter in, and I can show you that now. So that it produces with the help of boost. So I just plug in the adapter, which is already wired. So now it's putting 12 volts plus 8 volts, so that's 19 volts already. So it's pushing the amps already. See, going over 3. plug in now. So I'll let it spin up to 18 volts or so. No, it's not quite windy enough. There we go. 17. Yeah, she's pushing. Sort of a shadow shade. Just wanted to show the lights too. So over here, the green and the red flashing is the anemometer spinning. The green one is there's enough wind speed. The yellow one is the output. So it's right across the generator, and the green light on the end is it's operating in normal mode, so there's no kick or boost. And right now it's quite low, so in order to utilize, I'm gonna plug in this, and this obviously can be controlled automatically. The boost, kick in and kick out, which is what this relay is all about, but right now I don't have it operating. So right now it is adding 12 volts to whatever is in here, so it is producing power. And now when it's spinning up, it's not spinning up to as high a voltage. This is the batteries, and this is coming off the other solar panels. So let's have a look at the speed. You can see it's not spinning as fast, and it's already under load. So that's about 300 RPM. Up to 300. Yeah, that's about 300 right there. Now the wind is not sustaining. If it seems to it is, then I can unplug the boost. So it's going to let us spin up to about 600. Then it produces more power, obviously, because I'm not using any for the boost. It's sporadic. When it picks up, then slows down. So it's been about 16. You can see the speed is 500-600 RPM. This also running at 18 volts, produces the drop across this whole wire. It's coming from it. that's all I had, and that's 16 gauge wire. It's 2 conductor cable plus shield, which is oddly enough being used for microphone for 40 years. Now I'm using it here, and it's holding up pretty good. Now this top panel here, that see there's a dent and there's some scratches, smudges, and just inside today, and holes in the protection plate. I got it from China. The description was not, it said it was a bigger panel, and it didn't say anything about extra plastic protection, which it did have, but it was put on, it was all crinkled, so I pulled it off, and didn't say nothing about dents or smudges, scratches, and it did have that, so be warned. It came in like 4 days, but and it's producing about up to 75 watts. Right now, the sun is already back west, so it's not producing that much anymore. These here other ones, they've been on here for about 15 years. This is the bottom arm, 20 watt. One you can see the frame was broken, and I repaired it. The connection of the main rail was broke off, but it's still working. They're not producing as much. Altogether, these 3 plus these 2 5 watt ones produce about 25 watts, as opposed to about 70 watts. So they're pretty old, and that one there is producing more by itself than these 5. So you can see it's spinning up to about 600 RPM, and picking some power. Let's take the reading of the power. Right now it's slowed down. So most of this is now from the windmill. The solar is already reduced quite a bit. It's not quite enough to run with a boost, because the grid tie inverter is 18 to 50 volts, so it starts producing, and the solar panel is 18 volt, putting out 18 volts. It's 20 volts, but it drops down to 18 under load. It's still pretty much 20 volts. So that means I need to produce 20 volts or more to add to power. So I have both the solar and the windmill hooked up to this meter, which then feeds the inverter. That's it. The other solar panels go through this solar controller, and they discharge the batteries. That's how I have it right now, separate. Okay, so anyway, you see the power supply is off. There's no boost, and you can see over here, this is a dual diode. So that's generator, this is generator out, and goes to the meter and to the inverter, and then this cord is going to the other side diode to the same output with 12 volts added in series through the adapter, 12 volt adapter. So when I unplug it, automatically it uses the other diode. When I plug it in, then the first diode forward biases, reverse biases, and this one delivers the power. So I don't have to disconnect anything except I unplug it. So I think I'm gonna plug the boost back in. It's not quite steady. Sorry about that. I started rewiring this whole thing. This is a wiring mess. So I put these boards in here, and slowly I'm mounting and taking things onto there and moving this wiring so that it goes cleaned up down there. But I'm still experimenting with this, so that's why it's work in progress. I get mess all over here, as you can see. And I also I'm gonna have to add a fan here again. I had a fan there. The transistor is not sensitive enough, so I need to make it a Darlington pair. So I gotta add another signal transistor, like 2N2022 or 3904 double 100 beta amplification, so that it's sensitive enough to sense the heat from here with the thermostat, what do you call it? Temperature sensor, basically, that changes resistance with rising temperature. It lowers, so then it allows more current to run to the base and effectively turn on the fan with a variable speed. So okay, so I think I'm gonna leave this system running with a boost right now, because the wind is not very steady, and when it picks up again, it's supposed to in a couple hours, then I'll take the boost off. Okay, my battery is running low, so I'm gonna stop this and continue later. So long.